Today you'll be taking notes on section 12.5 and 12.6 and then doing the homework assignment that goes along with these two sections. These notes should be pretty quick. For 12.5, we're talking about the volume of pyramids and cones. So you'll be using the same formula, whether it's a pyramid or a cone, and it's going to be 1/3 times the area of the base, so big B, times the height of either the cone or the pyramid. So with cones and pyramids, they both have one base and they come to a point. So far we've been studying prisms. Prisms have two bases. Pyramids and cones only have one. So for number one, we're going to find the volume of this cone. Now the height needs to form a right angle with the base. So let's look at this. If we were to take this and divide the 120 degrees in half, we now have 260 degrees. And we have a right triangle because the height is a right angle with the base. So now we have a 30, 60, 90 triangle. 16 is going to be equal to 2s. Therefore, across from the 30 degrees is going to be 8. And then across from 60 would be 8√3. So that's going to be your radius. All right, so the volume formula, since this is a cone, is 1/3 the area of the base. Well, our base is a circle, so that's going to be pi r squared times the height of the cone. So we have 1/3 times pi, and we have 8√3 squared, not cubed, squared, times the height, which we figured out was 8. Okay, so 1/3, 8 squared is 64, √3 squared is 3. We have our pi there, and then we have the 8. Well, the two 3's can cancel because one's on top and one's on bottom, and then we end up with 512 pi for the volume of this cone. All right, for number 2, we're given that the radius of the regular hexagonal base is 12. So this line, actually that's not the radius, that's the apothem. So the radius would go from here to here, and we're told that that is 12. This apothem will form a right angle with that side. Okay, the total height of the figure is 188. And the heights of the two figures are congruent. So that means from here, if we split that up, 188 divided by 2 gives you 94. So this is 94, and this part is 94. Okay, and maybe, so it's not confusing, we'll write it like that. Okay, so we have two different figures going on here. We have a pyramid, and we have a prism. So we need to find the volume of both of them. This will be 1/3 the area of the base times height, and this will be the area of the base times the height. So for the pyramid, let's do 1/3 times the area of the base is going to be 1/2 your apothem times your perimeter because it's a regular hexagonal base, and then the height is going to be 94. Okay, so we actually don't have the apothem, but I'm going to take out this right triangle right here. So when I draw that over here, it comes from a hexagon. So we know that in the center, we divide 360 into 6 congruent parts, which makes them all, if we go like this, 60, divide that again by 2, and you get 30. So we have a 30, 60, 90. And across from the right angle is 12. So that's equal to 2s. Therefore, across from the 30 is s, that's 6, and this is 6√3. This is our apothem that we're missing, because the 6√3 on this figure is right here. It's 6√3. And then from here to here, it's 6. So that means that all of these sides are going to be 12. we will need that information in a second. So we have 1/3 times 1/2. The apothem is 6√3, and then the perimeter. Well, the perimeter is going to be, we'll do it up here, 12 times 6, which gives you 72. So that's times 72, and then multiply it by 94. Okay, so if we want, you can do a couple things to simplify. We can get rid of this, and that goes to 3. And then when this 3 comes out, it could actually be canceled because it's on top and bottom. So now we'll just do 72 times 94, which gives you 6,768√3. That's for the volume of the pyramid. Now let's figure out the volume of this prism. Well, the volume is equal to the area of the base. We already figured out the area of the base. It's 1/2 your apothem, which was 6√3 times the perimeter of 72. And then we're going to multiply by the height, which is 94. So again, let's simplify this. That goes to 3√3. And now we'll just have to multiply 3 times 72 times 94. And you end up getting 20,304. And then you have your √3 still. And since we're asking for the volume of this whole figure, we would have to add the volume of the pyramid to the volume of the prism. And when you add those, they are like terms. So 6,768 plus 20,304 gives you 27,072√3, and it's units cubed. Okay. Section 12.6 deals with the volume of a sphere, and the volume of a sphere is equal to 4/3 pi r cubed, where r is your radius, and a sphere is just a three-dimensional circle. It's a basketball or baseball. Okay, so we are going to use this volume when talking about an ice cream cone. We have an ice cream cone. It is 9 centimeters deep. So let's draw this cone. And 9 centimeters deep means that it has a height of 9 centimeters. And it has 4 centimeters across. So the diameter, we'll go up here, is 4 centimeters. A single scoop of cookies and cream ice cream, which is 4 centimeters in diameter, is placed onto the cone. So let's put our single scoop, which is also the same diameter of 4 centimeters. If the ice cream melts into the cone, will it overflow? And we are to assume that the ice cream's volume does not change as it melts. Okay, so let's first figure out the volume of our cone. So the volume of our cone is equal to 1/3 the area of the base times the height, which is 1/3, and then your base is a circle, pi times the radius, which is 2 squared, times the height of your cone, which is 9. So we have 1/3 4 pi times 9, which gives you 1/3 of 36 pi, which eventually simplifies to 12 pi for the volume of the cone. Now, volume of your sphere is equal to 4/3 pi r cubed. So we have 4/3 pi times 2 cubed. Well, 2 cubed is 8. 8 times 4 is 32. And then over 3 pi. So 32 divided by 3, when we do that, we end up getting 10 and 2/3. We'll still have pi. Let's get rid of this. So if you look at these and you compare them, your ice cream will not overflow. So the ice cream will not overflow because, and I'm completely fine with you saying 10 and 2/3 pi is less than 12 pi. And you can say this is volume of ice cream, and this is the volume of the cone. So on your homework for the sphere section, just be careful because sometimes it'll be a hemisphere. So last thing to note for our notes, a hemisphere is just a half of a sphere. So your volume is going to be half 4/3 pi r cubed, or you can think of it as 4/6 pi r cubed for the hemisphere. This concludes your notes for today.